I'm going to review the idea of finding domain. When you're finding domain, you're finding the set of all inputs, or x's, that can go into a function. If you have a fraction, a rational function, you can't divide by 0, so the denominator can't equal 0. Something like a square root or a fourth root, the thing inside the square root has to be bigger than or equal to 0. And finally, if you have a logarithm, the thing inside the log has to be bigger than 0. All other functions that we are dealing with have domains that are all real numbers. So let's take a look at part A. In part A, we have a rational function. It's a fraction. So we're going to set that denominator not equal to 0. To solve this, I'm going to try to factor. And let's see, 2 times negative 3 is negative 6. So I need to find two numbers with a product of negative 6 and a sum of that middle coefficient, negative 1. Those numbers are negative 3 and positive 2. So I'll copy down the first term, and I'll write that middle term as minus 3x plus 2x, and then copy down the last term. Now I can factor by grouping, which means we can take an x out of the first two terms, left with a 2x minus 3. We can't pull anything out of the second two terms, so we take out a 1, left with 2x minus 3. Then I take the 2x minus 3 out front, and I'm left with an x plus 1. Finally, I set each of those factors to 0, and when I solve, I get x cannot equal 3/2, and x cannot equal negative 1. Most of the time, I'm going to ask you to write your answer in interval notation. To do that, I would sketch what's happening on the number line. The domain of this function is every single number on that number line, except for negative 1, and except for 1.5. That chops the number line up into 3 intervals. We always write our intervals from left to right, so the domain would be all numbers from negative infinity to negative 1, negative 1 to 3/2, and 3/2 to infinity. Notice I'm using parentheses to indicate that we're not including any of those endpoints. My second example is y equals natural log of x minus 1 divided by x minus 5. There's two things happening here. We have a rational function, I have a fraction, and I have a logarithm. So I have to think about both of those things. Because I have a fraction, the denominator can't equal 0, which means x cannot equal 5. But I also have a logarithm. The thing inside the log, x minus 1, has to be bigger than 0, so x has to be bigger than 1. So my domain is all numbers that are bigger than 1, but not 5. So on the number line, it looks something like this. Everything to the right of 1, but not including 5. So in interval notation, that's 1 to 5 and 5 to infinity. Again, I'm using parentheses to indicate that those numbers are not included in the domain.